From the first time we went supersonic to right here, right now, it's fitting that at the largest celebration of our game, in front of the greatest fans in the world, we celebrate that history. To all of our friends here in Paris and those watching all around the world, this is the future, and this is...
Hey, everyone. All right, at the Rocket League competitive series in Paris, we gave the world the first glimpse of Unreal Engine 6. And this is the next step in our mission, to make great games and tools and to share them with you so you can bring your ideas to life. And I'm here to talk to you about what we're building now for the future. Today, things are kind of awkward. There's actually two different ways to build stuff in Unreal. There's building Unreal Engine 5 games for standalone distribution on stores with massive AAA features. And then there's the Unreal Editor for Fortnite feature set and tool set that enables you to build a game once and then deploy it to all platforms live into Fortnite with its 80 million monthly active users. Now, each of them has some really cool, unique features, but is lacking the features of the other one. And so our big initiative to bring them together is the core of the Unreal Engine 6 effort. It's UE5 plus UEFN equals UE6 plus some more cool stuff on the way. The vision is that if you build things once the Unreal Engine 6 way, then you can have a game that you can ship everywhere, including the console stores, the PC stores, the mobile stores, and also ship live into the Fortnite ecosystem or any other Unreal Engine 6-based game ecosystem built by any other developer. Now, in prior generations, we put graphics first in leading and announcing our technology. But with the Unreal Engine 6 generation, we're focusing first and foremost on the foundations of the engine to prepare for the next generation of game development and for gaming. And the most critical change here is the move to the verse programming language for gameplay development alongside the low-level C++ engine. And the reason for this is to enable massive scale code and content interoperability across games. Today we have a lot of content interoperability features. You go to the Fab content marketplace, you download a bunch of cool objects, you stick in your game, but then you have to wire them up and make it work yourself. In the Unreal Engine 6 generation, by having a unified set of APIs and a unified language that works everywhere, you'll be able to build smart assets that are completely portable between games and between projects and can be shared at any scale with the potential to have millions of developers collaborating together on a shared body of work that anybody can use. Another hallmark aim for the Unreal Engine 6 generation is to enable far larger game simulations. The original Battle Royale movie in 1999 that inspired the Battle Royale genre of games, fortunately, just happened to have 100 people dropping onto an island. It's a nice coincidence because that's actually the maximum number of players our code base could support running on a single thread on a server. If they had 1,000 players, we wouldn't have been able to do it. The goal of Unreal Engine 6 is to introduce software and transactional memory technology, which Curtis Schmidt will talk more about later, in order to enable scaling of games to any amount of computers that can fit into a data center. Hundreds, thousands, potentially even millions in the future. And this is technology that's in the research lab, and the team is working very rapidly to make into a practical shipping system. Another major aim of Unreal Engine 6 is something I first talked about at the SIGGRAPH Computer Graphics Show back in 2016. There I talked about a potential future of gaming as an open system like the web is open, in which any developer can run a server, build a game, host their own content, and the user can go anywhere they want, from place to place, bringing all of their stuff with them, and tearing down the walls and barriers that exist between games to have a completely interoperable ecosystem. And you know, the Rocket League preview of Unreal Engine 6, if you looked at the very last frame of it, there was a little URL bar on top. The URL was verse://rocketleague.com. And we're tantalizingly close now to fully realizing this idea of an open gaming ecosystem with the ability to travel from game to game and independent developer freedom to build everything they want everywhere they go. And our aim at Epic is to work with all developers in the industry to build this system together as peers. We want a system with no overlord. You know, we've been spending some time fighting against overlords in the industry with some amount of success. And we don't want to be the next one. Rather, we want to be a partner to every company in the industry, including all game developers and also other makers of technology and services, in order to build the best stuff and connect it all up together. And so a huge part of this effort is going to be Epic adopting open standards like the Pixar USD file format and GLTF, and also working with standards bodies and releasing specifications to bring new standards into the industry where they're lacking and needed. I'll be talking more about that later, but right now I'd like to introduce Marcus Wasmer to talk about the architecture of Unreal Engine 6. Thanks.
Okay, thanks, Tim. So let's just take a second look at the recent history of Unreal Engine. So Unreal Engine 4 opened the engine to everyone by making the tools free to use and the source accessible on GitHub. And UE5 reinvented how worlds are built, helping you go bigger, add density and dynamic detail, and do it faster than ever before. UE6 has a different proposition. It's about evolving how we ship and operate our games. That said, UE6 will keep doing the things you want an Unreal Engine to do. Rendering will keep getting better, cook times will come down, iteration loops are getting tighter, mobile is increasingly capable. However, we believe for UE6 that there are three things about game development that need to change at the same time. First, gameplay programming needs to get simpler for creating persistent, live, large-scale worlds. And Verse is the foundation for Epic's future programming model. It's a next-generation language purpose-built to power massive, persistent game worlds at scale, where global state just works and transactionally correct concurrency is handled by the runtime. We've built a modern high-level gameplay framework on top of Verse that gives you a true foundation to build games and experiences easily and to share their interoperable components between games. You'll hear more about our goals and architecture for this programming model from our technical director on the project in a few minutes. But for now, let's talk about the second guiding principle of UE6. Content and code should be portable across games and even engines. Our goal is to give the games industry a whole new way to grow our ecosystems with cross-promotion, portable player value, and to really lean into all the positive sum dynamics that Metcalfe's law predicts for connecting experiences and social graphs together. And we're going to do this with a determined effort to move UE beyond just extensibility and into open specifications for interoperability. Where existing standards such as GLTF or USD are capable of fulfilling our needs, we'll make them first-class formats within the engine. And where a standard doesn't yet exist that serves the needs of game ecosystems, we'll open up Unreal's own systems as open specifications with Verse APIs, defined asset conditions, and documentation that any engine, tool, or studio can implement against. And Fortnite Cosmetics will be our first real proof point of portability. We're going to start by moving the base system to an open UE6 module that's usable by all games. And this means that you'll have the option to use the player's entitled Fortnite outfits in your own games, and you'll get the tools to build outfits for your own games that work inside Fortnite. And we're tackling this problem first because we want to prove things out with a system that's complex enough to be a meaningful existence proof of the idea, and one that inherently comes with a ton of player value by respecting their purchases across an interconnected ecosystem of games. We see this as the first step towards building a shared economy for smart assets, functional assets with logic and functionality that work across games to recognize players' time and spending in a better way. In the end, this isn't really a Fortnite story. It's just about proving that such a mature, complex system can work at scale, and that every game that works with these systems will immediately benefit from them. Happily, we're taking the first concrete steps to such an open ecosystem right now. MetaHuman has been adopted by some of the most successful games in the world and is rapidly becoming a standard for digital characters. And that's why today we're announcing the MetaHuman Dev Kit, opening up our rig logic and MetaHuman DNA toolsets under the MIT license so that you can deliver MetaHumans in any game, any engine, any platform. To learn more, thank you. Yeah, so to learn more, please come to our talk right after this. All right, moving on, no tech presentation would obviously be complete without a conversation about AI. So to get one of the fun talking points out of the way, there's some speculation going around that game engines will be superseded by promptable world models. And we don't actually think that's what happened next. What does, we think, is much more interesting. That AI-assisted game creation will tighten iteration loops, reduce time-consuming manual setup of levels, character rigs, particle systems, getting bone weights, adjusting lighting, all of the manual work required to translate professional, creative intent into performant and cross-platform games. And crucially, Unreal Engine is uniquely placed to be the efficient, cross-platform, high-fidelity runtime that will remain the substrate on which much of the world's best games run. Thus, for UE6, we see LLMs, Gen AI models, and tools like Claude, Gemini, and so on as playing a central role in building content faster with the creative control that you need. And as you saw earlier, the future of these workflows is a fluent translation layer between natural language intent and your production pipeline. Our goal for UE6 is to greatly reduce the tedious work in authoring content to leave more time for creative exploration and increase the amount of iterations a team can make to polish their content. UE6 will ship with these workflows battle-tested against internal development and in UEFN. And while we've mostly been showing and talking about content creation, coding and engineering are important as well. Internally at Epic, we've been doing a lot of investigation to see what works and what doesn't. And we recently opened up pretty broad usage for code generation and AI analysis across our back-end, engine, and game development engineering teams. We've had a lot of great success stories. We've had particular success with people writing custom tools for their own work, fast code indexing tools for helping LLMs deal with large code bases like UE, fast incident response analysis, automated root cause analysis for crashes, automated test generation, and of course the wins you'd expect on back-end service development. But what's interesting is that most of those cases aren't even generating mainline Unreal Engine code yet, though that'll come. So you can expect Unreal Engine 6 to include all the key learnings for using AI for engineering along with content workflows. Okay. So we know you obviously have lots of questions about the transition from UE5 to UE6, so let's talk about that for a second. UE6 converges two threads of development we've been running in parallel. UE5 for high-end standalone game and content development, and Unreal Editor for Fortnite as the live environment where our new programming model is getting battle-tested. UE6 will combine these two products into one. As UE5 and UEFN merge into one editor, you will be able to ship traditional games and projects exactly as you do today. You'll be able to ship directly in Fortnite, or ship your own ecosystem and optionally make it compatible with ours. You'll have an easy path from one to the other. Actors and blueprints will be in early versions of UE6. Eventually, these will be deprecated when the new framework is sufficiently mature, and you'll have conversion tools to move projects from one framework to the other. Also, a new UE6 mainstream will be on GitHub later today, publicly visible, just like the UE5 stream has always been. Any remaining UE5 changes will merge to UE6 to not get lost, but not vice versa. And in addition, Fortnite development will be attached to the UE6 stream, so you can see all of our ongoing work live and cherry pick any changes as needed. However, this stream is not meant to be any kind of alpha. It exists just to be transparent with where we're going. And while we're not currently planning another official UE5 release after 5.8, we do reserve the right to ship a 5.9 if needed. You never know. So when can you get your hands on UE6? We plan to release in early access at the end of 2027-ish. We know how game dev works around here. However, Epic will be shipping things on the tech stack ahead of the early access release, just to make sure we get it right. 6.0 will be released 12 to 18 months following the early access release, and we expect just about everyone should be able to move their projects to 6.0, as it will still have all of the mainline UE5 tech, except for Cascade, where we're killing that one. That one's not going to make it. So get on the Niagara train. That said, we will be taking the opportunity to make some big architectural and other breaking changes that we wouldn't normally do in a point release, so you can expect a similar upgrade path from UE5 to 6 as we had for 4 to 5. We'll keep everyone up to date on our progress as development continues, and now Curtis is going to come up and give us a more detailed breakdown of the gameplay architecture. Thank you.
Thanks, Marcus, and good morning, everyone. I'm Curtis. I work on the gameplay architecture in Unreal Engine, and today I'm excited to talk to you about the new gameplay framework for UE6, which begins with Verse. Now, Verse is a next-generation programming language, purpose-built to power massive, persistent game worlds at scale. We originally released it 3 years ago in UEFN, where we could grow it to become the foundation for UE6. And Verse draws ideas from functional, logic, and imperative languages, and it should feel immediately familiar to anyone who's worked in languages like C# or Python before. But it also has some unique features aimed at solving the complexity and scaling problems of modern game development, starting with this unique software transactional memory model, or STM. Now, all functions in Verse run as part of atomic transactions, which can be rolled back and resimulated as needed. And this lets us do a lot of interesting things in our game's code. So for example, to check if an object can be successfully moved in the world, we can simply set its position, then do our spatial queries to see if it's hitting anything. If it is, we abandon the entire transaction, reverting the entire operation, and pretending the code never ran at all. Now, Verse's transactional memory model can also help us address another big problem in game development, building enormous worlds with larger player counts. And today, one of the big limiters to really building larger games comes down to server technology. Scaling a game to run on multiple game servers requires a fundamental rethinking of your entire game's architecture. Well, with UE6, we're working to build a full distributed software transactional memory system to address this. So here's the idea. We take your existing single-threaded style Verse game code, and then we distribute it across multiple servers. When an object's needed in one server, the Verse runtime rolls back the current transaction, migrates the object over to the server, and then reruns the transaction with the object now present. And this is all done in a way that retains the transactional consistency of the original program. And finally, with Verse, we wanted to make saving game data way simpler. So the Verse runtime can automatically synchronize and save any global state for the program, and then share it across all running instances of your game or an ecosystem. And to the programmer, what this means is that setting up something like save state for a player is as simple as setting a single global map of player to save state. No more having to set up databases or coordinate schemas between your game and other backend services. You can do all of this without ever leaving Verse. Now let's take a look at how Verse fits into the bigger UE6 gameplay architecture. So at the foundational level, we have the Verse runtime, along with all the UE systems that exist today, like rendering, chaos physics, meta sounds. With Verse, we're also introducing the Verse scene graph framework. Now, this is a modern game component framework with full support for prefab-style workflows and runtime composition. The scene graph has been designed to utilize all the power of the Verse language, including modeling the entire prefab data model through Verse's type system. Above this, every core system in the engine is exposed as concrete Verse objects. Each material, mesh, Niagara system that you author becomes a type of Verse class with a statically validatable API. This lets us use the Verse compiler to validate all of our data in a unified manner across the entire engine. For example, if you change a parameter in a particle system, you'll immediately know where in code needs to be updated to match. And finally, we'll be introducing high-level frameworks for common game systems like characters, weapons, and vehicles. Now, building with these frameworks helps speed up development, but it also creates content that can be shared widely across games and ecosystems. So imagine grabbing a car from Fab, and instead of simply getting a skeletal mesh and some animations like you might today, you get a fully working verse module for a car that functions across all of your games. With the UE6 gameplay framework, we're envisioning a world where enormous amounts of code and content is being built and shared between these projects, with Verse providing strong backwards compatibility guarantees to help the ecosystem grow sustainably. Of course, we'll need a place to store all this code and data, and here to talk about that is Matthias.
Thank you, Curtis. I'm Matthias Jansson. I work on developer tools, and I'm here to talk about our version control system, Lore. As we continue to scale our platforms and services, we run into many challenges when it comes to data storage and version control. We need something that can handle large binary data sets, scale easily across the globe, and provide secure data isolation in a shared multi-tenant environment. We also need to make it easy to use for everyone, not just programmers. We looked at the available tools and came to the conclusion that none had everything we needed. Git, for example, it's excellent at what it was built for, distributed development of source code. But game development has huge amounts of binary data and content and rarely needs everything on your local machine. Git doesn't really work well under such requirements. Other commercial and proprietary systems were also considered. But our foundational tools have to be open. Open specifications, open protocols, open formats. Anything less, and the people relying on them can't extend, audit, or trust them. So we decided to build Lore from scratch, and we designed the data model to meet our requirements from the ground up. We made scalability and performance core tenets from day one, and this is where most of Lore's technical innovation lives. It combines an efficient large asset handling with a free branching model, so teams can iterate quickly without sacrificing workflow flexibility or storage efficiency. And Lore will grow with you, from a zero-config, single service setup for small teams, all the way to multi-region, multi-million user deployments like UEFN, without requiring your team to fundamentally change how you work. At the heart of Lore is an efficient, content-addressed data store. Every file, every directory, every revision is identified by what it contains, not where it lives. Identical pieces of data are only stored once. Lore gives you direct access to that storage platform, so you can build your own applications and pipelines on top of it. Lore's version control uses this storage platform to let you work on multiple things in parallel, switch between them freely, and collaborate in safe, isolated spaces without worrying about how it scales. Lore's sparse, binary-first storage architecture fetches only the data you actually need for the revisions and branches you work with, supporting projects of any size. Large binary data is stored in smaller fragments, allowing partial deduplication and highly efficient parallelized data transfer of any file. That same data model is what lets Lore scale out across the infrastructure. As you grow, Lore lets you transparently add layers of additional servers from the local machine out through edge and regional caches and up to a durable global store. And because access is authenticated and authorized at every layer, that scale never comes at the cost of control. Every server enforces the same access policies. For a globally distributed team, that means that users in different regions can hit their nearest cache, and the global source of truth is never the bottleneck. Everything Lore does, data storage, version control, is exposed through a single complete API. And on top of that API, we built the tools you would expect. A command line interface, a desktop application, and in the near future, an integration in Unreal Editor. And these tools are all built on the same API and library. This API-first design makes Lore easy to extend and integrate into any development pipeline. Your tools and applications can easily use Lore through the API in the language you want to use. Though we're just scratching the surface here, I hope this gives you a sense of the power and potential of lore. And it's already used in production environments. It powers the UEFN ecosystem, where it's been known until now as Unreal Revision Control, providing version control and data storage for everyone's content pipeline. We have already started transitioning to use lore as the primary version control system for development within Epic, and we plan to be fully using lore by the UE6 launch. We built lore to address scalability and efficiency challenges we have at Epic, and as we talked with many of you, we heard similar challenges echoed across the industry. And that led to a bigger realization. If we're trying to foster a truly open ecosystem, one we all build together, then a system shaped behind closed doors would fall short. And that's why we're announcing lore as open source today. All the source code. Thank you. All the source code, along with documentation of data formats and protocols, are now permissively licensed under an MIT license and free to use. This release shouldn't be viewed as a perfect or complete package, but as an invitation to you to extend it, challenge it, and help shape it into something even more powerful together. So, if you're interested in learning more, head to lore.org and come to my session later in the show for a deep dive discussion on lore's architecture. And with that, I will hand it back to Tim.